Let's solve this Olympiad equation together. Most students will see this question and they will have either of these two reactions. Some of them will think this question is really difficult, while others will think the question is really easy. For the ones that think it's really easy, what they usually do is this. They would say 2 raised to the power x times 3 raised to the power x squared is equal to 2 multiplied by 3. Now, 2 raised to the power 1 multiplied by 3 raised to the power 1 is the same as 2 multiplied by 3. So they compare and now say that x is equal to 1 or x squared is equal to 1. Okay, inadvertently they will conclude that x is equal to 1. This is the correct answer, but this is just one of the answers of this equation. Recall that we have an equation with the highest power of x being equal to 2. Invariably, we should have two answers. Okay, so we can say 2 raised to the power x multiplied by 3 raised to the power x squared is equal to 6. Okay, which is the question. Now, I would go through the same route, but I will do something differently. So I can say 2 raised to the power x multiplied by 3 raised to the power x squared is equal to 2 multiplied by 3. Okay, now I can divide both sides by 2 multiplied by 3 such that I have 2 raised to the power x multiplied by 3 raised to the power x squared all over 2 multiplied by 3 to be equal to 1. At this point, we can use the law of indices. So we can have 2 raised to the power x all over 2 raised to the power 1 times 3 raised to the power x squared over 3 raised to the power 1 to be equal to 1. We have 2 raised to the power x minus 1 multiplied by 3 raised to the power x squared minus 1 is equal to 1. Moving on from here, we can decide to take the natural log of both sides. So you can say ln of 2 raised to the power x minus 1 multiplied by 3x squared minus 1 to be equal to ln of 1. Okay, now logarithm of any number of logarithm in any base of 1 is equal to 0. Okay, on the left hand side we have, since this is logarithm and we have multiplication in between them, we can separate the logs. So we have ln of 2 raised to the power x minus 1 plus ln of 3 raised to the power x squared minus 1 to be equal to 0. Now from here we can now say that we use this exponent to multiply the log. So we have x minus 1 multiplying ln of 2 plus x squared minus 1 multiplying ln of 3 is equal to 0. Okay, now at this point we can decide that we separate this using the difference of 2 squares, so that we have x minus 1 into ln of 2 plus x minus 1 times x plus 1 into ln of 3 is equal to 0. Okay, now we can try to factorize x minus 1, so that we have x minus 1 into ln of 2 plus x plus 1 into ln of 3, okay, is equal to 0. At this point, we can see that the product of two things are equal to 0. So it's either this one is equal to 0 or this one is equal to 0. So it's either that x minus 1 is equal to 0, implying that x is equal to 1, which we already got initially, or we have that ln of 2 plus x plus 1 times ln of 3 is equal to 0. Okay, now x plus 1 times ln of 3 is equal to negative ln of 2. Now dividing both sides by ln of 3, we have this over ln of 3 all over ln of 3. So we have here x plus 1 is equal to negative ln of 2 over ln of 3. Now x now becomes equal to negative 1 minus ln of 2 over ln of 3. And this is approximately equal to negative 1.63. Okay, so our answers are negative 1.63 or 1.